This video will be about area. Where perimeter was trying to calculate the outside edge's length, the area of a shape is trying to calculate the dimensions and size of the inside of the shape. How much space does it take up? So there's a couple of shapes you need to be familiar with: parallelogram, rectangle, trapezoid, triangle, and then for a circle, the area is the formula that starts with A. So on a parallelogram, the base and the height are perpendicular to each other. So the height is often given on the inside of a parallelogram. It can also be given on the outside, as long as if you extended the base over, they would meet at a 90-degree angle. On a rectangle, we have the length and the width. On a trapezoid, we have base 1, base 2, and the height is perpendicular to them again. And on a triangle, you have the base and the height is perpendicular to it again. Or if you are given a right triangle, the base and the height are just the outside legs. For a circle, the radius goes from the center to the outside of the circle. So the most basic thing they could do is just ask you to find the area. Find the area of a square with side length 10. We do have to know that on a square, all sides are the same. So square would use the same formula as rectangle, which is length times width, or 10 times 10. Which is 100 millimeters, they gave us units, squared. Area is always squared. Trying to find this two-dimensional space means we need to show that it is a squared area. They could say 10 square millimeters as well. They don't have to write the little 2 above if they actually use the word square. So they can switch it up a bit and make it a little harder by saying to find the length of the side of a square if the area is 36 meters squared. So we know our square has an area of 36 meters squared. We do not know the sides. Now we've been calling this length and width. On a square though, these are the same length. So I'm going to call the width also length. This is only feasible for a square. If it was a rectangle and they gave you the area, you would need some more information. On a square, we can say, well, we know the area is length times width, or in other words, length times length, because they're the same on a square only, or length squared. They also gave you an actual number for area, so instead of using A, we can use 36. So then we just have to figure out, well, how do we get L alone? It's like Pythagorean theorem, where we saw that doing the opposite of squared is to take the square root. The squared and square root cancel each other out. So the length of a square is 6 meters. Of this square is 6 meters. If it was a rectangle, they would have to tell you the area and maybe the length itself. They could say, well, the length is 9 meters. Then we can use the area formula. Area is length times width. And we know area is 36 and length is 9. This time the opposite would be division. 9 times W means opposite is dividing. So the width on this rectangle would be 4 meters. They can also give you a couple of shapes together. So here we have a rectangle and 3 circles. They are tangent to the rectangle, meaning they touch barely once. It's not that they are going through and it's hitting the circle at multiple spots on the circle. They're as big as they can be without going outside the rectangle. So if the length of the rectangle is 30 centimeters, so going all the way across is 30, and the height is 10 centimeters, what is the area of the shaded region? With the current information, we can easily find the area of the rectangle. The entire rectangle is length times width. Or 30 times 10. So 300. But we want only the shaded region. We want the space between the circles and the rectangle. So if we also find the area of the circles themselves, then we can subtract those two numbers. We want to take the entire area, which includes the circles, and get rid of the circle's area, so subtract that area out. The formula for area of a circle was pi times the radius squared. Unfortunately, we do not currently have the radius written in. We do have enough information to find the radius though. If all the way across the circle is 30, if we split that into 3 equal pieces, that would tell us the diameter for each circle. And if we divide that in half, that would tell us the radius. So 30 divided by 3 gives us 10. That means the diameter across each circle is 10. Radius is half of diameter. So 10 divided by 2 is 5. The area of one circle would be pi times the radius of 5 squared. I should have specified in the instructions. Let's approximate our answer to the nearest tenth. So pi, we can either use the pi button on a calculator, or we can approximate it using 3.14. It's usually best to use the pi button, so we would have pi times 5 squared, which would equal 78.53. We are going to round eventually, but we don't want to round yet, so I'm going to keep using the 78.53. We don't want to actually round until our final answer. Now this is the area for only one circle. Since there are 3 circles, if we multiply this by 3, that would tell us the area of all the circles together. We could also add them. We could say 78.53 plus 78.53 plus 78.53. So 78.53 times 3 is 235.59. So now we have the area of the entire rectangle, and we have the area of the 3 circles. To find the shaded region, this is where we can now subtract those 2 numbers. We want to take the entire area and subtract away the area of the circles. 300 minus 235.59 is 64.41. Now is where we can round to the nearest tenth. We're at the end of our problem. That's when we want to finally round our answer to wherever they specified. So nearest tenth is this 4. Next to it is a 1, which means we leave it a 4. So the area of the shaded region, I'm running out of room, so I'm going to write the answer here at the very top. The area of the shaded region is 64.4 centimeters squared. Here is another example. A square is formed by connecting the midpoints of a larger square. So each point here is considered to be a midpoint. What is the area of the inner square? So they want to know the area of this shape. Now we know the outside edge is 12, and we know each point is a midpoint. That cuts it exactly in half. So we know half of a side is 6. This other side is also 6. So we can use the same idea we had on the last problem. If we find the entire area of the entire square and subtract out each of these triangle areas, then we can find the area of the inner square. So the entire square would be length times width, or as we saw in one of our previous problems, just length times length, or length squared. So one side is 12, so 12 squared is 144. The entire area is 144. Now we need the area of one triangle. The formula for a triangle is 1/2 times base times height. We do know on a square, each corner is a right angle, so this is a right triangle. So the sides are just the base and the height. So 1/2 times 6 times 6. 1/2 times 6 is 3, and 3 times 6 is 18. So one triangle is 18. We need all 4, so we do multiply 18 times 4 to get all 4 of the triangles. 18 times 4 is 72. Now we do the entire area minus all the area of the triangles. 142 minus 72 is also 72. They didn't specify a unit. They didn't tell us if it was inches or feet. So sometimes we can just write our answer as 72 square units, or units squared. If they don't actually say centimeters or meters, sometimes they just use the word units. So 72 square units would be the final answer. We can also take a shape where we may have to add areas together. On the previous problems we had to subtract. We were trying to get rid of some of the areas. So in this shape, each square in the diagram represents 1 square inch. What is the area of the figure? So we want to take our shape and cut it into shapes we know how to find the area of. I can put a line here, and that actually splits it into 2 trapezoids. So we could do area of a trapezoid right away, or we could split it further and do a triangle and a rectangle. So we have a trapezoid, a triangle, and a rectangle. Before we can find any of these areas, we do need to know the lengths of the sides. So on our rectangle, we have 1, 2, 3, 4 of our boxes. So this side would be 4, and they did specify inches. So we do need to keep in mind the units, especially at the end. And then we have 1, 2, 3, 4, 5, 6 boxes tall. So area of a rectangle is length times width. So 6 times 4 is 24. We know this area is 24 square inches. We can do the triangle next. The triangle still has 4 boxes going across this side, and 1, 2, 3, 4, 5 going up. So area of a triangle is 1/2 times the base times the height. 1/2 times 4 is 2, times 5 is then 10. When you have a fraction, you can just plug that into a calculator using your divide button. 1 divided by 2 times 4 gives the 2. So this area is 10. And now let's do the area of this trapezoid. So along the bottom base, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 along the top base from here to here, so 1, 2, 3, 4. And then the height is always perpendicular, so we can use this left side going down. 1, 2, 3, 4, 5, 6. Which, since it also was the side of the rectangle, we could have just said, oh, the left side of the rectangle is 6, the right side is also 6. Area of a trapezoid is 1/2 times the height times base 1 plus base 2. So the height connects the two parallel bases. The height is 6, and base 1 is 4, base 2 is 11. We do need to add inside our parentheses first before we can multiply this all together. So 1/2 times 6 times 15. 4 plus 11 makes 15. Then we multiply. Again, you could just do 1 divided by 2 times 6 in your calculator. 1 divided by 2 times 6 is 3, times 15 is 45. So now that we've found the area of each shape individually, we can add all those areas together. 10 plus 24 plus 45, which is 79 inches squared. Or you could say it 79 square inches. So this concludes our discussion on area.